So I'm going to go through and show you guys how to write the formulas for ionic compounds, and it's really not bad at all. The main thing you need to keep track of is the charge of your different ions. So for the first one, you've got sodium and oxygen. Well, if you look up sodium, it's Na, and it's in group 1, which means it's going to have a +1 charge. Okay. If you look up oxygen, it's in group 6. So it has 6 valence electrons, which means it could either lose 6 valence electrons or gain 2 to become a perfect octet to have the electron configuration of a noble gas. So it's going to want to gain 2. So it has a 2- charge. And now all I have to do is cross my charges. So the 1 is going to become the subscript for the O. The 2, not the 2-, just the 2, is going to become the subscript for the Na. And so what you end up with is Na 2 O, and we never put a 1 as a subscript because it's implied. So if you put a 1, it's not convention. I'll not take off for the first time you do it, but after that point I will. Okay? For this next one, aluminum. Aluminum has 3 valence electrons, and so it can either gain 5 or lose 3 valence electrons. So it's going to want to lose 3 to have a 3+ charge because it's easier to lose 3 than gain 5. And sulfur has 6 valence electrons, so it can either lose 6 or gain 2. So it's just going to gain 2 because that's easier to do number-wise. Alright, now we got to cross our charges again. So the 3 is going to become the subscript for the S. The 2, not the 2-, just the 2, is going to be the subscript for the Al. And so what you end up with is Al 2 S 3. Okay? And then the last one, silver. Silver always has a charge of +1. It's one of the 2 transition metals that we always know the charge of. Ag always has a +1 charge. Zinc always has a +2 charge. Otherwise, I would have to tell you the charge of the transition metals. So Ag is +1. Nitrogen is -3. So again, I'm going to need to cross my charges. So the 1 will be the subscript for the N. The 3 will be the subscript for the Ag. And so what I get is Ag 3N. Okay? And that's it. Now, if you go back and you're like, okay, Ms. Polliner, why in the world do we need to cross our charges? If you are interested in knowing why, keep watching. If you really don't care, don't watch. But for here, the whole point is that ionic compounds do not need any charge. You don't want them to have any charge. And so what I've done here by creating this compound, I've said, okay, Na has a +1 charge. Okay? Since there are 2 of them, I'm going to multiply that +1 by 2. So Na as a whole will contribute plus a +2 charge. Okay? Oxygen contributes a -2 charge, so +2 and -2 will cancel. Therefore, that ionic compound has no charge. That's why we cross the charges in that way. If we look at Al has a +3 charge. Since there are 2 of them, I'm going to multiply it by 2. So Al contributes a total of +6 charge to this. Sulfur has a -2 charge. There are 3 of them, so we're going to multiply by 3. And so that's a -6 charge. And so those cancel. So Al2S3 has no charge. That's the whole point of this crossing the charges that we did, to make sure that we canceled out the charges so that the ionic compound would have no charge. I'll do the last one with you. Ag has a +1 charge. There are 3 of them. So Ag contributes a total of +3, while nitrogen has a -3 charge, so those cancel as well. So the whole point of when we're creating an ionic compound, when we're writing the formula and we cross our charges, the whole point is to make sure that we create compounds that are neutrally charged, that they have no charge.